So we're looking for a more efficient way of differentiating these more complex functions, okay? So let's treat it the same way. Let's think differentiation. What do we do? Right? We're bringing that power, we're multiplying by the old power. Okay, so this bit here always stayed the same for us. Okay, so this is now our, let's treat it as our variable x. Right, so this bit stays the same as that stayed the same. Okay, bring the power down by multiplying by the power, reducing the power by 1. Let's write it in there just now, but we don't need to write power 1. But with the chain rule, we then have to multiply by the derivative of the bracket. So treating that as a linear function, okay, multiplying by the derivative of that would be multiplying by 4. Okay, so 2 times 4 is 8, 4x minus 3. Okay, so that matches what we had earlier on, right? So applying that to a different function, okay, we know that this is also this. Okay, so getting ready to differentiate, bringing this up, index form, derivative h of x is h dashed of x, multiplying by negative 2, bracket remains the same, reduce that power by 1, okay? Posit that, reduce negative 2 by 1 gives you negative 3, multiplying by the derivative. The derivative of this linear term here, 3x plus 5 is 3. Okay, let's multiply the negative 2 by the 3. And let's write it in positive index form. Let's always do that. You know there's going to be questions afterwards, right? Getting you to substitute in. Okay, so negative 6 is multiplying this with a negative power, so this then belongs to the denominator with a positive power. Alright, underline the answer. Right, a trickier question here, f dashed of x, okay, but differentiate. Let's get ready to differentiate. So if you need these extra steps, then please take them, okay? So you might be able to go from here to here, right? So, chain rule, multiplying by the old power, bracket stays the same, reduce the power by 1, okay, so you might need to at the side reduce that by 1, which is subtracting 2 halves. Then multiplying by the derivative of the bracket, okay, don't forget that bit, that's the extra bit here, right? Multiplying by 2. So this works out quite nice. Negative half multiplying 2 is negative 1, so we'll get negative of this here. And you know what I'm going to say next? Positive index form, subform. Okay, so negative 1 is multiplying this one with a negative power. Let's bring it to the denominator with a positive power, and then let's write that in positive index form, okay? Didn't really need that bracket there, but because it was cubed, and I wanted to make sure I was doing all of the 2x plus 3 cubed and not just the 3, okay? So that is not the same as this here. You don't want to be doing that, alright? Right, that's a pretty decent question. I would work through that question a few times until you really get it, okay, and then practice some more so that this then becomes a really high level of differentiation you've got for your higher maths, okay.